Hello, Ivan.
Hello, Jesse.
Happy New Year.
Happy New Year too.
Yeah, and for all the Chinese who are celebrating Chinese New Year, I think we're gonna have another round. So if you did manage to complete your New Year's resolution, you get a second chance. Yeah. Anyway, thanks for joining us today, everyone. We hope you are having a great Thursday evening. And I'm Jiaxing from Google Developer Relations team. And Ivan, you want to introduce yourself?
Oh, I'm Ivan from the working community of DataScience SG. Yeah.
Yep.
So,
And
so for today, we actually have Chang Sheng, who's a software engineer at Tiger. He'll be sharing with us on how he built a search and question answering web application based on the data he gathered on the MOH advisories on COVID. So he built this using open source tools such as Hugging Face Transformers, Bird Haystack, and Fast API, which most of you are familiar with. So as usual, if any of you have any questions, please feel free to drop them anytime, and then you will address at the end. So, yep, Chang Sheng, please take it away.
Okay. Hi everyone. Yeah. My name is Chang Sheng. So thanks everyone for spending your evening here today on today's session. So today's session will be about this mini project that I did last year during the COVID period. It's a search and question answering project on the MOH advisories. So MOH has this website with all the advisories for what are the number of people limits and what are all the rules and regulations during the phase 2 period. So it's a bit irrelevant now, but it's a interesting project that can still apply to any set of documents that you have, or any if you want to build search and create on your own collection of documents. Yeah, you can use the same kind of technologies. Yeah. So today I'll be talking about the motivation, a bit of introduction to search and question answering, how I implemented this project, as well as certain remarks and learning points during this journey. So a little bit about myself. So I was during the project, I was a software engineer at Tiger. Currently, I'm just joined Shopee. And if you want to know more about the project, you can feel free to visit the link. Maybe I'll share the link later. Yeah. So there'll be the GitHub repo. Everything is on GitHub. So a bit about why I want to do this project. So at the point of time, I was working on the search related product as a software engineer. So a lot of times we don't think about how to want to improve the user search experience. So we are spoiled by the web search experience, right? Because when we go to Google search, we type in certain questions, and then we'll immediately get like answers straight away. Then we don't need to click into the documents to look for certain answers. So we are really spoiled by web search. But realize that there's actually a gap between the web search and maybe certain enterprise search experience, or like search experience you have when you're searching for your work-related documents. Maybe you won't have that same intuitiveness and convenience. So actually, this was the main motivation why I was exploring this project. And at the same time, it's there's the COVID period, so there's bunch of documents about what are the things that we should and should not do. So I thought this would be a good chance to try out exploring a search and QA system on the COVID related advisories. So let me first begin by sharing more about search systems, right? Because even though it is a search and QA project, and actually I think I would say QA is the slightly more interesting part of this project, but this search part is also a very important step of this whole system, because it's kind of like the preliminary step, right, to improve the QA performance. So maybe I'll elaborate more about that later on. So a typical search system, there are the following components as you can see on the screen. Typically, you have some kind of content that you want to search from. So you have some crawlers maybe to crawl through the content, and you have to index your content. So you have some kind of program that will be your indexer, and during this step of indexing, you will do some text processing, right? So you do stuff like maybe your stemming lemmatization, your stopword removal and stuff like that. Or maybe there's additional metadata from the document that you want to extract. So yeah, this is all part of the indexing step. And after that, once it's inside your index, you can use tools like Elasticsearch, yeah, to store your documents. So once it's inside your index, you can then perform your search right through. Now, let's say you use Elasticsearch, you can use Elasticsearch to query the documents and maybe rank them based on a certain criteria, right? Have certain custom boosting logic based on your requirements, right? And so once it's in that index, you can then perform queries on it, right? So from the query step, you can see that after the user enter a query, there's usually some kind of query processing where you do same stuff. Maybe you do like your tokenization, your index, your stemming and lemmatization, stop removal, or like maybe some people do some kind of entity recognition or intent recognition at this point of time. But basically, this part is the part where we convert the natural language queries to queries that are more suitable to search through your index, right? So the search system actually this search logic actually is I would say quite critical to the search and the QA part, as you see later on. Yeah. So right, question answering. So I think there are many question answering systems out there. So if you just refer to the papers with code .com, where there's the listing of all the different research problems with regards to machine learning, and under the question answering topic, you can see that there are like I think 10 issues here, 10 sub problems here. Typically, we are used to like when we do web search, it's more like open domain, but also a quite common QA system that we experience is knowledge-based question answering. So I think when you search for like who is the Prime Minister of Singapore, or like when you search for a certain company name on Google, then you'll see that you'll see a knowledge card, right? There's a tile on your result screen that shows the certain information about the object you're searching for. So I think that's an example of your knowledge-based question answering. And also another common interesting QA system that we see nowadays is a generative type of QA. So that one is more like I think everyone have seen the GPT-3, GPT type of models in action, right? We can ask them to answer random questions about what is the meaning of life, etc. So that's the generative QA. For today, we're focusing more on the open domain QA type of system. Okay, so for open domain QA, right, the problem is as such, right? We want to give answers to factoid questions expressed in natural language, right? Without specifying the context which contains the answer. So, example, like you can see from the screenshot of this example taken from the project itself. So, typically you ask questions these kind of questions are like your who, what, when, where, why, and how type of questions. So you typically want some kind of factual type of answer, right? Who is the president of US? When can we go to the cinemas? Yeah. So, and the part about open domain is you don't know which document, right? You're expecting the answer to be in, right? So I think in NLP there's a task called reading comprehension, right? Where given a passage, like given a body of text, or given a document, right? You can ask a question, and then the system will give an answer, right? So that's a reading comprehension type question. So actually, open domain question answering, the type of open domain question answering I'll be sharing today is consists of the reading comprehension, right? So here's a diagram of the framework that will be used, right, in this open domain QA system, right? So it's they call it the retriever reader framework, right? So yeah, so this is the part where the search come in, right? So we break down the open domain QA into two problems, right? And the first problem is the searching part, right? Because as I mentioned earlier, for open domain QA, there is usually no uh, providing of a context, meaning providing of a document that contain the answer, right? So this is the part where we make use of the search, right, to first filter out or find a top K set of documents that may contain the answer. And then after that, we use the models to perform a reading comprehension task that can retrieve the answers. So if we perform technically you can perform reading comprehension on all your documents, but that will take a very, very long time. So which is why we have the retriever, which is typically, in my case, in this project, we'll be using Elasticsearch, right? So the search will help to find the top K documents first, and then we'll apply the reader to extract the answers from the top K documents. So, okay. Yeah. So retrievers, right? Retrievers are basically well, fast algorithms, or in this case, in this case, Elasticsearch, right? They can identify candidate documents from a given query, right? From a large collection of documents. So it significantly reduces the search space for the reading comprehension model, right? So there are a few ways we can implement the retrievers. First, classical information retrieval way, which is using your TF-IDF, your BM25, which is what Elasticsearch is using, right? These are like sparse embeddings. Or another way we can do so is using neural information retrieval, which is the more modern way, but there are pros and cons for each way. For my current project that I'm sharing today, I've used Elasticsearch because it's a rather small project, small subset of documents, so I think it's sufficient. And Elasticsearch is faster as well, even though it may not always give you the best accuracy compared to neural information retrieval methods. Right. So for the project, right, I make use of this library called Haystack. So Haystack actually is a very great library for anyone to kickstart building their own open domain QA system, right, or even neural search system, right. Um, After this, I'll be sharing more. Maybe I'll share the link to the GitHub of that project. But yeah, do check it out if you are interested in implementing your own QA system. So pros and cons. Yeah. So for the sparse kind of embeddings, which is DM25, which I'm using, right? It's simple, right? Very explainable. But the con is that it relies on exact keyword matches, right, between the query and the text. So if your query, if your document, right, or your query doesn't have matching text, then chances are you may not find what you're looking for, right? So, but for the dense embedding, so for example, if you use like the sentence transformers or dense passage retrieval embeddings, right? We are able to like find relevant documents, right, where the words doesn't need to match, right? But of course, it's more computationally heavy and during the training and as well as probably during the inference as well. So it may take longer. You may need more hardware, right, to support this. Okay, so let's go on to the reader, right? The question answering part, right? So for the readers, basically they are powered by BERT or variants of BERT models, right? That have been fine-tuned on question answering training data, right? So basically what the reader does is taking passages of text as input and return top and answers, right? So for haystack, right, you can use farm or transformers, right? So farm or transformers are different frameworks you can use to load your BERT variant models, right? You can look for all the pre-trained models on Hugging Face Model Hub. So it's very good. You can filter by pre-trained models that are fine-tuned on the question answering task, right? So for Haystack, I think they trained one of them, and I'm using one of it that Haystack has pre-trained for me. So a deeper dive into how the BERT QA works. So I think many of you should be familiar with uh, the BERT itself, like it has made headlines everywhere, right? So for BERT, basically there's a pre-training and a fine-tuning tasks, right? So for pre-training is mainly training on the mass language modeling task and next sentence prediction task. And to do the QA, to do the question answering, you need to fine-tune it based on use the squad data set. Use the squad data set where they are labeled start and end spans on documents, which will fine-tune the BERT model for QA. So what it does is for fine-tuning for QA tasks, right? What it learns is additional embeddings for the start and end uh, position, right, where the answers would be. So the span, which has the highest probability, right, where the end token is larger than the start token, right, will be the span which contains the answer, right? So how it's built? For this project, basically, since it's just one page of documents, right, it's probably around close to 200 documents. So I built a simple crawling script to crawl the site, do some pre-processing, and index documents to Elasticsearch. And after that, once it's in Elasticsearch, I built a simple fast API application that will then perform the session QA on Elasticsearch index, which is served through a simple web UI. So this is a demo of my site. I previously, a few months ago, when I launched a project, it was up, but I think it's completely irrelevant now since it's phase 3 now. So I've brought it down, but this is a local running instance of my project. So basically what you can do is ask certain questions, like, what can I do in phase 2, right? And then you look for the answers, right? So you can get answers in the top, snippets of answers, and the relevant documents as well. So I crop my data from the Phase 2 sector-related advisory site. Type of documents there are like websites on PDFs, and it may link to websites. Some of these links may link to websites that contains PDFs as well. So I also crawl those PDFs, right, on those child sites. So basically, I index all the websites, the full sites, and the PDFs that I crawled. And during the pre-processing, I need to split the documents into smaller segments. So imagine, I think this is a important step, right? Because if each document, right, it may be 1 page, it may be 10 or 20 pages, right? And if you just do your reading comprehension task on like a 20-page document, it will take very long time, right? So to make this process faster, what I did is I split the documents into around 200 words, 200 word segments of documents. Why is this important? Because for the BERT QA, right, the models have a maximum sequence length usually for this model particularly is 386, I think, tokens as the maximum sequence length. So it's important to keep your documents short so that your retriever, right, the search part, can retrieve the right segment of documents for the model to perform the reading comprehension task, such that the model doesn't have to go through too many segments, right, which will take a lot of time. So during the crawling process, I split it up into segments and I created a hash so that I can remove the duplicates later on. Very simple preprocessing. And after is a simple snapshot of the endpoint for the question answering. Basically, the key question answering part is over here. But basically, this is from the Haystack API. So, like I said, highly recommend checking them out. They have a lot of tutorials as well on how we can get started to build our own QA and search system. Yeah. So I think during the deployment, right, and currently, as you can see, and during my testing, it takes around like 2 seconds actually for the answer to return. Right, the search is fast, but the answer is not that fast, right? So I think so for this project it's okay, but I think in production environments, I think it's something that needs to be worked on, right? There's some ways that you can reduce it, like we maybe can implement a cache to store like frequently asked question answer tags, or you can use like smaller models maybe, and you may sacrifice a little bit of accuracy. And of course, if you want to improve the accuracy, right, of your QA system, it's best to still further fine tune it based on your data, right? But of course, that one is resource intensive. For my project, I didn't. I just take the pre-trained, the fine-tuned model and use it directly. And I think, as you can see, it seems pretty okay. Yeah. So I think that is the end of my presentation. Thanks, everyone. I'll be answering some of your questions.
Thanks, Chang Sheng, for sharing. So I see we already have one question there. So I'm going to flash on the screen. So this person asks, so the center transforms is limited by the input length. So what happens if the document is longer than the limit?
Yeah, thanks for the question. So what happens is the model will need to perform these reading comprehension tasks on different segments of the document, right? So it will still break down the document and then do like a using like a sliding window kind of way. So like there's this thing called a stride, right? Document stride. So let's say your sequence length is 300, right? And then when you process the document, you take maybe the first 300, and if your stride is 100, you go to the 200 to 500 word, and then subsequently, right, you move on segment by segment and perform the reading comprehension task on each of these segments, and ultimately you will get the segment. For each segment, there'll be like some answers, right? And for every answer, there'll be a certain score. And I think there are two different ways of handling it uh, based on the library you're using, right? Is it the farm reader or is it the transformers readers? But I think ultimately what they'll do is you'll get the scores of the answers from each segment, and then return the span with the highest score as the answer. So which is why I shared just now that I need to split the documents into smaller segments, right? Because if not, your model will need to like perform this recomprehension onto the various segments by itself anyway. So I might as well use the retrievers. Might as well split the documents first and use the retrievers to find the relevant segments instead of letting the model do everything, right?
Okay, thanks. I hope all that actually clarified. We will wait if there are any more questions. I think, oh, we have one more question. So, how can you optimize search for when collections rapidly increase in size real time? So not just related to files or documents, but also for enterprise chat systems.
Optimize search. I think it depends on maybe also the type of like search backend you're using. For example, if you use Elasticsearch, there are things like optimizing the way you index your fields. Uh, there are ways like, or you can uh, scale horizontally your Elasticsearch cluster and stuff like that. So not very sure what's the context, but yeah. Think if you're using Elasticsearch, you can scale horizontally or change the way you index or change your queries and stuff like that. It's quite open-ended, I would say.
Okay, yeah. Actually, I have one question. I was looking at the retriever and then some of the examples are TF, IDF. What's the difference between that and BM25?
Oh, this one. Yeah, so for the haystack, I think you have no choice. You have to use BM25, but BM25 is like uh, I can say like a improved TF-IDF, maybe, that solves
Oh,
some of the, yeah. So it's a base and it's built with inspiration from TF-IDF lah, yeah, that resolves some of the shortcomings of TF-IDF when we have very long documents.
I see.
Yeah,
Okay,
so
thanks
Elasticsearch use
for
BM25 out of the box. So I think in the haystack, if you use TF-IDF, it's mainly for if you load in some test data, then it's all in memory. It's like an in-memory document store, then they will use TF-IDF. But very Elasticsearch use BM25.
Okay, got it. Thanks. I've actually never heard of that. So, okay, I think that's all the questions we have. Okay, thanks for sharing again. And thanks everyone for coming. We wish you a good week ahead. Thank you. Bye bye.
Okay, thanks.